Hi everyone, this is Algebra 2, Chapter 5, and we're going to be looking at Lesson 3, or in other words, 5.3. And we're going to do a little bit of review here from 5-2, and we're going to be looking at composition of two functions. So you should have seen this before, again, from the prior lesson. So we have two functions here, and what we have is a composition happening or taking place. So it says find R that is composed of S at 5. Okay, so how we want to set this up is we're going to say that R is on the outside, and then we're going to say that S of 5 is going to be on the inside. And so it's going to be basically, again, a function within a function. So we're going to have R, let me make this a little bit clear, R and S. I don't want this to look like a letter. So R is composed of S at X, okay, equals, so R is on the outside, okay, so I'm going to have -2, and if you remember, see this function here, S of X, I'm going to go ahead and put that inside of R of X. So where there's the X, I'm going to have 2X plus 3 plus 1. And to just give you a reference on where I'm getting all this information from, this is my S of X, and then we'll say the green is my R of X. So once we have that, then what we can do is plug in what our X value represents. So let's make that pink. And so what we'll have here is R is composed of S, and instead of X, it's a positive 5. So we'll have -2, 2, and 5 plus 3 plus 1. I'm going kind of fast because, again, it's review. What we'll have is -2, 10 plus 3 plus 1, -2. Let's make that a little bit cleaner, forgive me. 2, and then 13 plus 1. That gives me -26 plus 1. So my solution to this is -25. Again, we went fast because this is review. You should be familiar with this. But there you have it, -25. What I want you to do is go ahead and try B on your own. I will give you the solution to that one, so you can check your answer. The solution is going to be -4x minus 5. 4x minus 5. So this one, the only difference is that here you had a 5 and here you just have the x value. Okay, let's move on here. It says if two functions f of x and g of x are inverses of each other, then f is composed of g at x would equal x, and then the inverse of that is g is composed of f at x would equal x as well, meaning we want to make a note here. When you plug the function into each other and simplify, you would get x for both, basically. Okay. If that doesn't make sense now, hopefully it will in a moment. So number 1 says determining whether two functions are inverses of each other. And then we're going to find this here, and then we're going to determine if f and g are inverses of each other. Now, if they're inverses of each other, both answers should be equal to x. Okay. If you want to add that in your notes, you can. That's basically what's being set up here. But let's go ahead and do the first one together. Letter A. I'm going to make this one orange, make it whatever color you want. And I'll make this next one yellow, kind of switch things up a little bit. So the first one I want to set up is right here, where I'm circling. Let's do this one first. F is composed with g at x. So we will have f composed of g at x, okay? That tells us what that formula is, right? On the outside, I'm going to have the f of x. So I have my negative. And then right here, I have my x. I have my x. So I need to plug my g, because my g is on the inside. I need to take my g and put that in for x, okay? Make sure you put it in parentheses. That is highly important. Remember, operations matter. And then we'll have our plus 9. And let's show where we're getting all this from here. So that's my g of x right there. And then this is my f of x on the outside. So we just took that g of x, put it inside of the function f of x. From there, what we want to do is kind of solve it. I have a negative 1 out here, right? So I got to distribute that. Again, this is a negative 1 in reality. So I get negative x minus 9 plus 9. Well, my solution for the first one is negative x, okay? Is negative x. Well, make a note here. Negative x does not equal x, so it's not looking good already. I could probably say this is not going to be a function, or should I say these two functions aren't going to be inverses of each other is the more appropriate way of putting it. But now let's try g is composed with f at x right here. Let's do this one. So we'll have g on the outside this time, and then we're going to have the f of x on the inside. So g is going to be x right here, so I need to plug this inside. So I will have negative x plus 9, and then on the outside I'll have plus 9. Let's show where we're getting this from. That's that, and then that's on the outside. From there, we just need to solve. Again, we're adding, so be careful here. We're not multiplying, so we're going to have negative x plus 18, and that's our solution for that one. Now, if you notice something, let's see if we can make that a little bit better. There we go. If you notice something here, this also does not equal x. So we have an issue here. And the only issue is that f and g are not inverses. Okay? F and g are not inverses. What I mean by that is this would have to be equal to x, meaning this would literally say equals x, and this one would have to say literally equals x. Then we could say that they are inverses. Now go ahead and try. Actually, I'll do b on b with you. B seems a little bit more difficult here. So let's highlight. We're going to do the same thing again. We're dealing with basically the inverses of each other. So I'm going to highlight this as orange, and let's do this one as yellow. And let's just fill one in. So we're going to have f on the outside, and then g of x on the inside. So we're going to have 5 all over, and if you remember, the g goes on the inside, so the g is going to be where that x value is. That's going to be all over f of x. To show you where I'm getting this from, as always, this is my original, and then this was plugged in for the x value. Well, we got it interesting because you guys are looking at this going, well, there's a fraction over another fraction. Well, what we need to do here, just to kind of show you what this is really saying, I'm going to rewrite this to make sense. And actually, this should all be in blue. I think that would be helpful. So let me just rewrite this for a moment here. Okay. Equals. Okay. Let's rewrite this so it makes a little bit more sense for us. This is really saying 5 over 1 divided by 5 over x. Okay? Meaning the exact same thing, we just rewrote it. Well, when we do this, what we can do is flip this fraction. And when we flip it, it also changes the sign. So this is going way back to 6th grade. When we take the reciprocal of something, it also changes the sign. So this would end up being 5 over 1 times x over 5. Okay? If you noticed, these end up canceling, right? So what are we left with as our answer? Is just x. So not too bad. The great thing about that is that's what we wanted for that first one. We wanted an x. So this might actually be inverses of each other. Now let's do the other one, just the inverse of it. We'll have g on the outside this time, and then we'll have f of x on the inside. So we will have, once again, 5, and then I need to plug f of x in for x. That is 5 over x. And I'm getting that from there, and then I'm getting this from there. If you notice, right, these are inverses of each other. The orange is on top, the yellow is on the bottom. Now yellow is on top and orange is on the bottom. Let's just rewrite this out. 5 over 1 divided by 5 over x. Looks like we're having the same exact thing as we did on top. And we'll take the reciprocal. We'll still have 5 over 1 times x over 5. We can cross cancel the 5's. And there we have another equals x. Perfect. That's what we wanted to find. What this says is f and g are inverses. Okay, f and g are inverses. So now you're seeing the difference. Here, they're not the same. They're not both x's, and here they are. So I think those are good comparing and contrasting to one another. What I want you to do is go ahead and try these two down here at the bottom. So for the first one, you're going to plug this value in for x here. And then after, you're going to plug this value in for x there and go ahead and solve. So it might be a little bit challenging because you have to recall back from operations that you learned in prior years of your mathematics, simple mathematics. But you should be able to be successful on this. If not, that's what class time's for, and we will definitely cover it. Moving on here, we have vocabulary terms, and I have stuff already pre-written and read here for you to help and guide you with understanding. But what this vocabulary term is saying, it's saying f is the inverse of x, or another way of phrasing this is the inverse of f of x. That's what this is saying right here. So I'm going to put it in red. Actually, let's do this. There we go. So just match the color schemes up with one another. Well, what's the definition of the inverse of f of x? The notation for the inverse of the function f of x, that's what that's saying. The function where the input x values and the output y values are f of x are switched. So they're just reversed in another way. Some of you might go, I don't know what the heck you're talking about. Well, I put it down here. So if we're saying the inverse of f of x is equal to f of y, and the inverse of f of y would equal f of x, meaning they're just reversed. So in other words, when you see the inverse of f of x, that just means f of y. And when you see the inverse of f of y, then that's f of x. Okay, so you're just flipping them. Well, let's do an example here. We're looking at inverse functions, linear, comma, discrete. And we have g of x, and we have some notation here. And then we have a function h of x equals 6x plus 13. So right here it says the inverse of g of 4, basically. Okay. Well, what we want to find is, let me do this in red. We want to find what is the x value. What is the x value when y equals 4 of g of x? So that's our question that we're having here. This is what we're looking for. What is the x value when y equals 4 of g of x? The reason why is you have this written right here. But if this is quote unquote the x value right now, very similar to what we have right here, right? Pretend this is a g and then this is an x. And if this is x is 4, then really what we want to find is the opposite of that, the reversal, the switch of it. So really what we'd be looking for is, instead of x equals 4 in here, we're looking for y equals 4. So if you look in here, y is 4 is right here. So what we can say then, and I know this is a foreign concept, I know that you're just learning it for the first time, but bear with me, we'll do some more, is g is the inverse of 4. Really, we're saying x is 4 on that statement, but the inverse of x is 4 would be y is 4. Well, when y is 4, what is x? -1. So there is a lot of reversal of thinking in this, and this is where one can't get by without fully understanding this concept. This is not something you can kind of just guess on and get lucky. Well, I mean, I guess you could, right, with any guessing. But what I mean is to fully grasp this concept, you really have to understand the reversal and switching of an x to a y and a y to an x. That's really it. So once you understand the switching that's happening, it's really, really not that difficult. Okay, let's do letter B here. Well, we have h, okay, we have h is the inverse of x. So what we want to do, let's go switch back to red here, zoom in, is we want to switch x and y and then solve for y. A little trick in what I'm thinking here, right, is you see how this is an x value? What I want to do is switch this for a y and solve for y, okay? You'll see what happens in a moment. So what we're going to have here is we're going to switch the x and y and solve for y. So I have, and I need the top part, we're going to have h of x equals 6x plus 13. And I had to zoom out because this right here, this information is given right here at the top. That's why I had to zoom out to be able to see it. Well, I want to swap out the x for the y, okay? This right here, I want to swap out and make it a y. Y equals 6x plus 13, okay? After that, this is where the inverse comes in, the switch. Okay? So put that in your notes. We're going to switch those two. Switching them is going to now give me x equals 6y plus 13. Okay? Well, I want to solve for y because that's the inverse, right? This right here, if I can get what y equals, then that's the inverse of this. So what we need to do is move 13 over to the left-hand side. I will have x minus 13 equals 6y. Divide by 6. So what we get is, I'm going to draw an arrow here on where this is going because I need more room. We're going to get y equals x minus 13 all over 6. Well, the great news is that I needed to find the inverse or the switching of this. If this is x, then I need to find y. Okay? If you're confused where I'm getting that whole statement from, you have to go back up here. See how there's an x here, and then there's a y right here? That's why I needed to find y. So this is not finding y as of yet because we have to take the switch or the reversal of both right there. So once we have that, the great news is now we have h inverse of x equals x minus 13 over 6. Now some of you are going to say, well, why couldn't we take that y equals 6x plus 13? And that's a good question. The reason why that original y equals is not our answer, this right here, is because this is not the inverse. This is saying h of x. What we want to find here is the inverse, right? Again, the inverse, where we're saying that the inverse of h of x is what we want to find, which is going to lead us then over to here. So we're going from here to here. Alrighty? I know this seems like a foreign concept, and this is where a lot of practice makes perfect, okay? So I'm going to show you A, B, and C, and then I want you to try and do A, B, and C on the right-hand side on your own. This does take practice. It can get confusing, okay? So we want to find the inverse of this. So what we're going to have here The inverse of h is composed of h at -1. Okay, so this one, we're going to attach 5.2, the composition of two functions, to what we have taking place here. So we're going to have h of -1, or h to the negative first power, the inverse on the outside, and then we're going to have h of -1 on the inside. And this is why that review portion was so important that we started off with. Well, I know that we'll have h of -1, okay? I know what h of x is, right? That's given in the original problem right here, 6x plus 13. So we're going to have 6. I don't need to put x there. I already know what x is. X is -1. At this point, we should know that. Plus 13. Let's go ahead and solve. -6 plus 13. That equals 7. Okay? That equals 7. But that's what x equals, right? So let me make the connection for you. That is what x equals right here, up at the top. So I could plug my 7 in here, okay? So let's write h of -1, and that is going to be 7. We have the reversal, right? We have this, folks. We have it right here. Okay, we have what this is. So let's just highlight this in green. Maybe you'll be able to find it. Okay. And what we will have here, I'm just going to do it long form. And then I'm going to do some highlighting here. I don't have this part in my notes, so I'm kind of expanding on my own notes here in real time. But let's highlight this 7 in green, I guess. Just to kind of show you the green on where we're coming and where we're adding stuff into. And then from there, it's simple plug and play and solve. 6 over 6. Thus, our answer is -1. So probably should have done everything in blue to keep things consistent. But that is how you're going to do all three different types of problems that are dealing with inverse functions. So again, for many of you, this is going to look and be very confusing. That is understandable. This is even kind of a difficult concept to teach because there's a lot of flipping and a lot of switching happening around. And you have to understand the movement of variables, but also what those variables represent. So practice makes perfect. Go ahead and try A, B, and C on your own. I will give you the solutions to A, B, and C. This one, you should get G. This one's equal to 0. B, I'll give you this one. This will be x plus 14 all over 3. And then lastly, this one's going to equal, C is going to equal 6. I'll make that a little bit cleaner for you. 6. Okay, now we're getting into some word problems. I know it's all your favorite, but it's finding, evaluating, interpreting an inverse function for a given linear relationship. So the problem says Ashley is walking d of t below represents her distance in kilometers. Let's highlight that. Her distance in kilometers from Tomsville after t hours of walking. Well, that's important as well. After, let's see if it'll highlight for me, after t hours of walking. And then it gives us the function or formula there. So it's asking A, which statement best represents D is the inverse of X. So we have the amount of time she has walked in hours when she is X kilometers from Tomsville. We have her distance from Tomsville in kilometers after she has walked X hours. The ratio of the amount of time she has walked in hours to her distance from Tomsville in kilometers. The reciprocal of her distance from Tomsville in kilometers after walking X hours. Okay, so which statement best describes? So we're saying that after t hours of walking, well, And then the d of t, so this right here, see these two are matching? It's saying that this represents distance in kilometers from Tomsville. This is really our y. Okay, this is really our y. So if I take the inverse of y, I should have x, which is this. Okay, well, if this was distance in kilometers from Tomsville after a certain amount of hours of walking, then our choice and our answer is the amount of time she has walked in hours, okay, when she is X kilometers from Tomsville. If you look at that, yellow came first and then green. Here, green's coming first, then yellow. If you wanted to utilize color and seeing the flip or reversal of the statement, okay? So the wording within itself was reversed. You can go a step further and represent what each value represents and then reverse it that way, and you would still come to the same answer or the same conclusion. So let's do letter B here together. So find d, negative 1x. Okay, so we'll have d of t equals 12.8 minus 4t. Again, I got that from up here at the top, okay? And we're trying to find this. So what this is really saying, right, is y equals, and this is kind of pulling from the fall semester, if you're curious on how we're getting all this, 4x. This setup is from pretty much the fall semester, inputs and outputs, things like that. And then what we're going to do, like we had in our notes from the previous problem, is we're going to switch our x and y's, okay? So what we're getting now is x equals 12.8 minus 4y. We want to solve for y, so it's minus 12.8 from both sides, minus 12.8 from both sides. We're going to have x minus 12.8 equals negative 4y. Divide by 4 on both sides, or negative 4 to be specific. We will then have y equals x minus 12.8 all over negative 4. Now, what this is really saying, right? I know what y is. Let's go back up to our notes, way up at the top to make the connection here. I know what y is, right? I know what y is. Excuse me, right here. So then I know what the inverse of f of x is, or in other words, of d of x, or d of t, to be specific in the problem. I know what the inverse of d of t is, right here. So we're going to have the inverse. That's going to be the x minus 12.8 all over negative 4. Very similar to the problems that we just practiced above. Letter C then, we need to just use this formula here. We know what our x is, and then we want to solve. So I want you to do that on your own. Again, this is just telling you what x represents. Take this, copy and paste it over here, plug this in for x, and solve. And you should get 1.1 hours to walk 8.4 kilometers from Tomsville. Okay, so this should be your answer. Let's move on to the next one. It says a tank is being filled with a liquid. L of T represents the amount of liquid in liters in the tank after T minutes. So let's do LT represents the amount of liquid in liters in the tank, and then after T minutes. So which statement best describes basically the inverse of what this statement's being given up here? So really we want to have probably the green after T minutes, the amount of liquid in liters in the tank. So the ratio of the amount of liquid in liters to the number of minutes x. No, there's nothing really in there that's going to kind of relate to that. the amount of time in minutes it takes to have X liters of fluid. After T minutes, the amount of time it takes to have X liters of fluid in the tank. So it's going to be this one. So the amount of time it takes, and then we're going to have X liters of liquid. Okay, so I highlighted the inverses that are taking place for you. The reciprocal, the amount of liquid after X minutes, no, and then the amount of liquid in liters, obviously, after X minutes is not it either. Now, this problem right here, B and C, is the same thing we just did for A and B at the top, these right here. So go ahead, follow this step, this formula, and just apply it to these down here. It's pretty much the exact same steps, and we'll cover it together in class, and I'll go over any misconceptions, misunderstandings, or questions for you in class. Let me give you the answers. You will have here -1 x equals x minus 15.5, and then you're going to have 2.5 down here at the bottom. And then over here, when you apply that formula up here, you'll have 27.8, and it's in minutes, so minutes. Okay. The letter C you should not get wrong, because technically you don't have to do any math other than plug in the 85 into the formula right here. So this one you definitely shouldn't get wrong. This one might take a little bit of practice, but I believe you'll all be successful in getting it. Okay, graphing the inverse of a function given its graph. Seems difficult, but it's really not. Below are some functions. Graph the inverse of each function in the same coordinate plane. So we're given this function here, and really what we want to do is write out the points that we can, and then we just want to take the inverse or switching or flipping it to find our answer of what would be the inverse of it on the graph. So let's first plot just kind of some points that we know that we have. Okay. And I'm just going to write down what those coordinates are. X comma y. And so we first have -3, 5. -3, -5. -3, zoom in. -3, -5. Our next point here is, looks like it's 3 comma -3. 3 comma -3. And then our last one is 4 comma 6. 4 comma 6. All I need to do is take the inverse of those, meaning I just need to switch them. So let's do this one in red. So I'm going to go over here. And instead of having x first, I want to put my y first, comma x. So I just switched these. Okay. So I just need to put my, instead of -3 comma -5, I need to put the y first. That's -5 comma -3. Okay. And we're going to do the same thing for this one. The y comes first, -3 comma 3. And then we're going to have 6 comma 4. Now let's graph these new ones in red here. Let's graph these new ones in red. So I'm going to have -5. I'm going to have -5, -3. Where's that at? That's right here. Then I'm going to have -3 comma 3. That's right there. And then I'm going to have 6 comma 4. 6 comma 4 is right here. Do I have that right? Let's see. Oh, forgive me. There's my mistake. Hopefully you guys were saying it. This should be 5 comma 6. There we go. So then this is 6 comma 5. I was like, why is that not working out? Okay, so 6 comma 5 is right there. There we go. So let's connect our dots here. And what you should see happen, if you kind of remember the axis of symmetry here, is you have it cut in half. So that's how I know it's the inverse of one another. It's specifically cutting it in half. We have our axis of symmetry. It's reflecting over it. It's the inverse of it. I'm just trying to find different vocabulary words or things to assimilate information here. But as you can see, it would reflect over that green line. Thus, I know it's the inverse of it. Let's go ahead and try B together as well, and then you'll do letter C on your own. So I just need to plot these points here that I know that we have. Okay, so let's plot those 3 points. And I'm going to write those coordinates down as x comma y. So I have 2 comma negative 3. I have 4 comma 0. And then we have 5 comma 7. Well, I want to take the inverse of those. So the inverse of just x comma y is y comma x, right? So then I just need to put my y value first, 0 comma 4, and then 7 comma 5. Remember, I'm just reversing them. Okay. From there, we just plot those new coordinates. So I have negative 3 on my x value, negative 3, 2. What is that, way up here? And then 0, 4. 0, 4 is right here. And then I have 7, 5. 7, 5 is right here. Let's connect the dots. Okay. And then we should be able to see our axis of symmetry that's taking place here. Again, we should be able to see our axis of symmetry. It's not going to be perfect, but you can see where we're going with it. And so hopefully this part of it is encouraging. It should be relatively easy, and hopefully you're able to do letter C on your own. And that's going to be the conclusion of 5.3. We'll do lots of practice in class to get comfortable with dealing with the inverse of 2 functions as well as the composition of 2 functions. With that being said, good luck everyone on your notes.